Okay, this is lesson 6.6 and 6.7. 6.6 is use proportionality theorems. This is the triangle proportionality theorem. We kind of discussed this at the very first lesson when I gave you that picture that you had to set up. And I was telling you that you had to have the parallel lines. So this is saying if a line is parallel to one side of a triangle and intersects the other two sides into two distinct points, that means B and D, and A and C, then it separates these sides into segments of proportional length. So therefore, we can use, if BD is parallel to AE, we can use part of the triangle BA to the triangle side of the small one, CB, to equal the part of the triangle DE to the side of the triangle CD, because those parallel sides break it into distinct parts. Only if they're parallel, though, can you do this. Now, this also applies to just lines. If you have three or more lines that are intersecting two transversals, such as you see in that picture, then they cut off the transversal proportionally. So that means if DA is parallel to EB and also to FC, then you can take AB to the BC side equal to DE to the EF side, as well as you can take AC the whole thing to DF the whole thing to part of it, BC to EF, or AC the whole thing to BC the whole to part of it to DF the whole thing and EF the other part of it. Now, if three or more parallel lines cut off congruent segments on one transversal, then automatically the others are congruent as well. So in the picture's case, if AB is congruent to BC, then we know that DE is going to be congruent to EF. Now again, this only applies to parallel lines. Now the angle bisector theorem is very similar to what we did with the median and the altitude with our proportions. But remember, this is only one triangle now, where the median and the altitude had two triangles. So they're saying if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. So here's a picture, ABD, an ABC triangle. So we draw an angle bisector from A to D. So what happens is that line AD is going to bisect into proportional parts, not congruent, but into proportional parts. So that makes AB the side of one triangle to AC the other side, and then you can look at the part of BD, which is on the same side of the AB, to DC, the part of AC. Okay, we only have two more slides. 6.7 starts to get back into our transformations again. But this is a new one. This is the one that's not isometric. This is known as dilation. Dilation is a transformation that stretches or shrinks a figure to create a similar figure. It's no longer isometric. Remember, translation is isometric. That is, it's congruent still. Doesn't change its size. Translation, rotation, and reflection are all the same. Does not change the size. They're just all isometric. Dilation, though, makes it bigger or smaller. So it does change it. However, they're still similar because the angles are still congruent. Scale factor of a dilation is a ratio of a side length to the image to the corresponding side length of the original figure. Again, the ratio of the side length of the image, the new one, to the corresponding side of the original. Remember, that's your fraction. So now, let's say K is our scale factor. It's a reduction if that K is between 0 and 1. That would be like if you had a 1 to 2 factor. Okay. The enlargement K, if it's greater than 1, then it's going to get bigger. So that would be like your 2 to 1. Hopefully you copied these down. If not, please go back. because these are the notes that I will not take the time in class for you to copy. We will do examples that correlate to them.